In our third activity, rules for area and perimeter, a square that has a side length of 9 has an area of 81 square centimeters. The relationship between the side length and the area is of the square is a function. So complete the table with the area for each given side length. Then write a rule for the function a that gives the area of the square in square centimeters when the side length is s. So remember, if our square, if we have a 1 by 1 square, to find the area inside, you multiply 1 times 1, which is 1. So here we would go 1 times 1, or we call it a square because it's really just 1 squared, is 1 square centimeter. So if our square is 2 by 2, you can go 2 times 2, or we're just going to write 2 squared. And 2 squared is 4 square centimeters. And then here, if a square is 4, so you could write 4 times 4, but that really is just 4 squared. And 4 times 4 is 16 square centimeters. And if your square is 6, you would go 6 squared, or 6 times 6 is 36 square centimeters. So if your square has an area of S, we would say A of S equals S squared. So what does A of 2 represent in this situation? So the input is 2. The function does a square of it. This means the area, if the side length is 2. So in this case, if we did 2 squared, that equals 4. So the value is 4 square centimeters. So now we're going to sketch a graph of this function. So again, our inputs go on the x-axis. So we would put side length in centimeters. And we'll count by 1. So 1, 2, 3, 4, 5, 6, 7. And now here, this would be our area, which is in square centimeters. And our area gets quite big quickly. So we could count by 5s here. You could count by 10s. So I'm going to do 10s. So 10, 20, 30, 40, and 50. So if the area is 0, I would put 0. And then 1 times 1, you're just going to have to kind of estimate. That's at the bottom there. 2 times 2 is 4, kind of towards the middle between 0 and 10. So if I did 3 times 3 is 9. So that's going to be up here towards 10. Just estimate that. If the side length is 4 times 4 is 16, kind of in the middle between 10 and 20. If the side length is 5 times 5 is 25. Put that there. If the side length is 6 times 6 is 36. If the side length is 7 times 7 is 49. So if you notice this function, if I were to graph this, you can kind of see it's increasing because it is a parabola. It's going to move up like that. So we have another function here. A roll of paper that's 3 feet wide can be cut to any length. If we cut a length of 2.5 feet, what is the perimeter? So again, the roll of paper is 3 feet wide. So then we have the length is 2.5. So to find the perimeter, what you can do is you would take you have your 3 feet and your 3 feet, and then your 2.5 and your 2.5. So this 3 feet and 3 feet is always going to be the same. So the perimeter in this case is going to equal 3 plus 3, which is 6, plus really 2 of the 2.5, so 2 times 2.5. Then we can use a calculator to find that, but that's really going to be 6 times 5, which is 11. But if you need a calculator, totally cool. So 6 plus 2 times 2.5 gives us 11. So again, if our side length was, I put 2.5 there. So we have a different one here. So this is supposed to be 1. So I made a little mistake here. So what if my perimeter is 1? So again, to draw that picture, we have our 3 and our 3, but then we have our 1 and our 1. So again, 3 plus 3 is going to be 6, plus we have two sides that are 1 feet. So 6 plus 2 times 1 is going to be 8. So again, what if it's 6.3? So again, the 6 is going to be the same, but then we have two side lengths that are 6.3. So we have 6 plus 2 times 6.3. And use a calculator there, which is 18.6. Then down here, if we plug in 11, we have 6 plus 2 times 11, which is 28. And then to plug in L, we would have 6 plus 2 times L. So what does P of 11 mean? What it would mean is the perimeter if the other side was 11. So the perimeter, if we're using L, so that just means the length. So it's the perimeter if the length is 11. And here it's 11 feet, so I'm going to include the units. And then the value, we did that. So if the length is 11, the perimeter is 28 feet. So now what we're going to do is just fill these in. So this, again, on our x-axis, our inputs are lengths, and our outputs are perimeters. So if the side length was 1, the perimeter was 11. So we put that there. We could plug in 0, 6 plus, or 0 here. So 6 plus 2 times 0 would be 6. If I plugged in 2, this right here, sorry, I messed this up. This should be 6 plus 2 times 1 is 8. If I plugged in 2 here, 6 plus 2 times 2, that would be 10. So down here, this is incorrect. I'm going to cross that out. So that was 8 and then 10. And then 6.3 was 18.6, so 6.3, 18.6. Let's plug in 3 and just some of those other ones. So we can go 6 plus 2 times 3 gives us an output of 12. So again, if the side length is 3, the perimeter is 12. If I plug in 4 here, so 6 plus 2 times 4. Again, if the side length is 4, the perimeter is 14. So down here, 6 plus 2 times 5. That's going to give us 16. Plug that in. So again, these are our inputs. These are our outputs. This is a function rule, which is very just similar to equations that we've worked with.